All right, folks, good morning or good afternoon based on whatever class period you're in. Happy Friday, by the way. Congratulations. You made it through the first week of 8th grade. So, impressive stuff. Good stuff. Good stuff. All right, so today we're doing lesson 5, okay, of unit 1. All right, so the learning goal today is that you want to be able to apply transformations to points on a grid as long as you know the coordinates. So we're still doing transformations today, but we're looking at grids now, or coordinate planes. So if we have points on a grid, how do we move those points if we're being told to perform a transformation? And what does that look like? So that's what we're looking at today. You'll notice I'm not going to go over the homework from 1.4 today just because it's Friday. It's a shorter class, so we'll be, it's early out. So we'll just go through the lesson for 5.1. And luckily there's no homework tonight, so whoop whoop. It'll be a good time. Okay, if there is time at the end of class, though, I do want you to practice the practice problems or work on the practice problems for lesson 5 just in the back of your workbook. Okay, after the lesson on lesson 5, if you flip to page, oh, I don't know. Oh, hey, it's right here. What is it? What is it? What is it? What is it? Practice problems for lesson 5. There they are. The lesson 5 practice problems do start on page 44. So if you have time after completing this lesson, filling out the workbook, I do want you to try your best and get some of these problems done because we'll probably talk about them when I get back a little bit. Okay. I will be going over the 1.4 homework in next week's video, in Monday's video. Okay. And that'll be the last one. Then I'll be back. Woo woo. Okay. So this is the starter right now. It's on page 37 and 38. The idea is you want to select all of the translations that take triangle T to triangle U. All right, that's this triangle here. Well, obviously the one labeled T to the one labeled U. Okay, that's what you're doing. All right, and all the transformations or the translations are listed here. We've got the first one right here. We've got some other options. Now, what you're going to notice is that they're not telling you to move a shape. They're telling you to move these coordinates to another coordinate. Okay. So for example, translating, I mean, if I was going to, let's say this point here, translate the point or the coordinate negative 3, 2, that's this point here because it's negative 3 is the x, 2 is the y. If I wanted you to translate that to right here, I would say translate negative 3, negative 2 to the coordinate 0, 3. Okay? And then you would perform this transformation. All right? So we're doing that, but here and with these coordinates, okay? So I want you to try your best and let me know which of those 4 transformations here will actually take triangle T, this one here, to triangle U, okay? Give that a go, pause the video, take like 3 minutes, just go through those, see if you can figure out which one. So go ahead and pause it. Okay, I'm assuming if you're here, you have completed the starter and have now unpaused the video, or you're just watching through and wondering why I'm taking these long, awkward pauses. Okay, so right here, let's look at a few of these. Okay, so the first one is translate negative 3, 0 to 1, 1, 2. All right, so negative 3, 0 is this coordinate here. We're translating that coordinate to right here, 1, 2. Well, if we do that, does the triangle line up? Let's see. It does. So that is a transformation that works. That's taking T to U. So number 1 is an answer. If you got that correct, just, a little silent celebration. Woohoo. All right. Fantastic. Good work. Okay, let's see what other ones work. So we know that number 1 works. I'll circle that in green. Let's look at this one. Translate 2, 1 to negative 2, negative 1. So now we've got the coordinate 2, 1, this one, to, what was it? Negative 2, negative 1. That's this one here. Okay, so if we do that, okay, will that line it up? Let's see. It does. Okay, but this is not a correct answer. Do you know why it's not a correct answer? I'm just kidding. So here's why this isn't a correct answer. Okay, if you said this before I did, congratulations, all right? So this transformation, going from 2, 1 to -2, -1, actually takes triangle U to triangle T, not triangle T to triangle U. It's the opposite. So it's going in the wrong direction. That's not the correct transformation. That's not what we're trying to get. Okay, so that would be incorrect. All right, good work there. So it's going to be a no from me. All right, let's see. The next one is taking -4, -3 to 0, -1. Okay, we've got -4, 3. I like that. -0 or 0, -1. Perfect. If we complete that transformation, that will in fact line up. We're good to go there. All right, nice. So that one is a correct answer. All right, number 3 is correct. Okay, fantastic. Let's look at 1, 2 to 2, 1. 1, 2 to 2, 1. Okay, this is 1, 2 to 2, 1. Let's see what happens. If we take 1, 2 to 2, 1, check this out. Does not work. Okay, so that one's not a true statement. That one does not work. All right, so get that out of there. All right, thank you. Okay, so our answers are 1 and 3. If you got those, way to go. All right, if you said 2 was an answer and you said 3 and 1 was an answer as well, don't be too hard on yourself. You did good. Okay, so let's, all right, 6 minutes, way to go. All right, let's continue on. Okay, so what I'd like to go over next is reflecting points on the coordinate plane. Okay. So we're not going to go over these practice problems because it's Friday and we're going through this quick. Okay, so this activity is on page 39, and the idea is we need to answer these questions. Okay, we need to answer these questions. We're plotting these points on the graph, right? Because it says plot each point, all of these points, label them A, B, C, D, and E. So we'll do that. Okay, and then using the x-axis as a line of reflection, plot each image of the point. So here you're reflecting across the x-axis. That's this axis, the horizontal axis that goes across the coordinate plane. All right. It says label each image point with its coordinate. So we would label the new coordinates as like A prime, B prime, those sorts of things. Okay. And it says that include a label using the letter. For example, the image of A should be A prime. Don't forget that. Okay, now the rest of these you can read through and give them a go yourself. If you're confused, you can, as you're going through, you can kind of skip ahead and see what I'm doing. Just take a peek at it and kind of go from there. Okay, so, all right. So go ahead and take 5 minutes to do that. All right. Well, if you need 10, give it a go. All right, but just pause the video right now. Try it on your own. And if you're really, really, really confused, you can press play and just like take a peek at what I'm doing. Okay, but I do want you to be able to do some of the stuff on your own. All right, cool. Go ahead and pause the video, do that. And if you're still here, well, congratulations. You probably unpaused the video and you finished with your work. Or you're just, kind of skipping ahead a little bit to see how I do this. All right, so I'm going to start with A. Plot each point and label each with its coordinates. So let's go here. All right, we've got A is 0.5 and 4. So I know 0.5, the x coordinate always comes first in a coordinate. The y coordinate is the second one. So 0.5 is the x, and then we go up to 4. So that's our first point. We're going to label that A. Okay. The next one's B, -4, 5. So we'll go to -4 on the x coordinate, or on the x-axis, and up to 5. We'll label that one B, okay? Because it did say label them, right? C is 7, -2. So we go to 7. Oop, that was incorrect. 7 and down to -2. All right, keep in mind those negatives there. They'll get you. All right, D is, I got to label that C. D is 6, 0. Label that one D. And E is 0, -3. So down here. Ooh, that's trouble. All right, cool. We've got all of our points labeled. That is A done. We can check that off, all right? I want a better check than that. That's way better. Look at that check mark. Ooh, that is crisp. All right, so The next one is to use the x-axis as the line of reflection to reflect these points across the x-axis. So we talked about this on Wednesday, right? No, not Wednesday. We talked about this on Tuesday. When we reflect across the line of reflection, you're going the distance to that line of reflection and the same distance away. So if we're going from 5 negative, or from negative 4, 5, going across that x-axis, we're going to end up here. Still 5 spaces away from the x-axis, our line of reflection, and that's where we'll find B prime. Okay, that's one of them done, right? Fantastic. Let's do C next. Okay, C, we're going across the x-axis, 2 spaces to it, 2 spaces across it, and we get C prime. Okay, we do the same thing with E. 3 spaces to the line, 3 spaces beyond it, we have E prime. Okay, and the same thing with A. It's really close to E, but we go there, and then we go, oh no, I'm going to move that label here. Okay, A prime will be here at negative 4 and, or sorry, at 0.5 negative 4. That's the coordinate there. And does it tell you to? No. Plot the image of each point. Okay. All right. So D, this is an interesting one, right? So D is right on the line of reflection. And think about it. When you put your hand or your finger on the line of reflection, right? Or on a mirror, if you put your hand on a mirror, right? It's not far away from the mirror. It's right on it, right? So the reflection is actually in the same place as your hand is when you put your hand on the mirror like that, okay? So our line, well, our D prime is going to be in the exact place that D is, okay? So they're pretty much the exact same point. A point that is on the line of reflection doesn't move, just like the center of rotation does not move, okay? It's pretty great, okay? So we've done that. We've gotten all of our points, all of our prime points in the right spot. We can check that off. Oh, still a good crisp checkpoint. Label each image, the image of each point with its coordinates. Okay, so the image of D, well, D is the same point. It's that same 6, 0. So nothing's changed there. Okay, C is, instead of being negative 2, 8 or negative 2, 7, it's now positive 2, 7. Or sorry, 7, positive 2. Gotta get those x coordinates in the right place, right? Okay, so we've got that. A ends up being 0.5 and negative 4. All right. E ends up being, let's see, 0 and negative 3. And B ends up being negative 4, negative 5. Okay, fantastic. All right, so we've done that. And it says include the label, so A should be A prime. We did that. I've done that already, so we're all set there. That's the first one. Congratulations. We did it. So just to show you all kind of what happened, right? We were going across the x-axis, so I'll put these points underneath each of their letters. So A prime ended up being, what was it, 0.5, negative 4. B prime ended up being negative 4, negative 5. C prime ended up being 7, positive 2. D was the exact same point. And E ended up being, let's give it a little more space there. Whoa, hello. 0, positive 3. Fantastic, right? Great. So if we go on to the next page, number 2 asks us if the point 1310 was reflected using the x-axis as a line of reflection, what would be the coordinate of the image? What about 13, negative 20 or 13, 5, 7? Okay, this looks complicated, right? It's like, wow, I can't plot those points on this line. Maybe I can't even plot 13, 10. So let's look at our examples, right? Let's look at what we just did, okay? Well, A went from 0.54 to 0.5 negative 4. What's the only thing that changed there? You can answer it silently to yourself. You can answer it, well, don't answer it loudly, but You'd also just sit there and wait for me to say it, right? So if you said 0.5, well, the only thing that changes here is the y coordinate. It went from 4 to -4, okay? Which is fantastic. So when we reflect across the x-axis, that's a pattern that happens. Our y coordinate becomes negative, right? So B went from being -4, +5 to -4, -5, right? Good stuff. If the y coordinate's already negative, then the new y coordinate, after a reflection across the x-axis, will become positive. So the sign just switches on the y coordinate. Unless it has no sign, like D does, 6, 0, that point is on the line of reflection, so it stays the same. E, same thing, right? The x-coordinate doesn't change because we're reflecting across the x-axis. The y-coordinate becomes positive because it was negative. Okay, so knowing that, this question becomes a lot easier, right? Well, if 13, 10 were reflected across the x-axis, it would become 13, -10. If you wrote that, great work. Good job. 13, -20 becomes 13, +20. And 13, 570 becomes 13, -570. Not too bad, huh? Not too bad. Not too shabby. Okay, great. So the point R has coordinates 3, 2. This is great to know. Okay. Without graphing, predict the coordinates of the image of point R if point R were reflected using the y-axis. Okay, so let's think about this for a second. Okay, when we reflect a point across the x-axis, right? This is 2, 3, right? When we go across the x-axis, the y-coordinate changes to negative. So if when we reflect across the x-axis, the y-coordinate changes, what do you think is going to happen when we reflect across the y-axis? Well, I would guess the same thing. I would guess that the x-coordinate changes, okay? That's assuming that's what you guessed, right? So let's go with that guess. Check your answer by finding the image of R on the graph. So if we reflect R across this y-axis, which I'll just kind of highlight here. This is our new line of reflection. Well, we're going 3 spaces to the line and 3 spaces beyond it. That's right here. And our new coordinate is what? Well, we're at x -3 and y is 2. Oh, that's crisp. That's a good answer. That's correct right there. It also matches our estimate, which just makes me feel all sorts of warm inside. It's great. Okay. Fantastic. So we'll label the point of R as R prime, as it says down here. Check. What are the coordinates of R? Well, as we see, it's -3, 2. Check. All right. Now it says, suppose you were reflecting a point using the y-axis as a line of reflection. How would you describe its image? It's kind of a thought question for you, but I mean, if I was doing this worksheet, if my 8th grade self was doing this worksheet right now, with the knowledge I have now, that would be unfair. All right, but suppose you reflect a point using the y-axis as a line of reflection. How would you describe its image? Well, I'd probably describe it as going across the y-axis, honestly. I mean, across the y-axis, I would say that the x-coordinate changed signs. Now that means, okay, if I'm going from here, reflecting across the y-axis, okay, where my y-coordinate is, where my x-coordinate is -3, my new x-coordinate is going to be +3. So the sign just changed. It went from negative to positive. Same goes for if you're going the opposite direction, right? If you're going from +3 being the y-coordinate to -3 being the y-coordinate, it goes from positive to negative. Reflecting the other way. Okay, good work on that. All right, that wraps up that activity. If you reading along or working along with me, that's great. Keep up the awesome work. All right, instead of doing transformations of a line segment, we're going to go ahead and read the lesson summary. Okay, and again, feel free to read it on your own. Highlight some things that you find important because y'all are good at that. Okay, I'll just go ahead and read through it and kind of explain as I go. What are we at? 20 minutes right now. Way to go. All right. We can use coordinates to describe points and find patterns of coordinates of transfer. Oh, hang on. Let me start again. We can use coordinates to describe points and find patterns in the coordinates of transformed points. We can describe a translation by expressing it as a sequence of horizontal and vertical translations. For example, segment AB is translated right 3 and down 2. Great, perfect. We like that. All right, so here, I think we've said this before, right? It's hard to describe a distance diagonally down, right? If I said diagonally down 4 units, I mean, is that down 2 over the 2? Is that down 1 over 3? I'm not really sure. So the best way to describe this is being translated to the right 3 and down 2. That tells me it uses the coordinate plane to get you to the right direction. So to the right 3, down 2. And every point is moving that same way. Okay, as what happens when we do a translation. All as far as the shape moving, that's great, but also each individual point moves that same direction as well. Okay, as they've shown us here. Now it says reflecting a point. I'm so sorry about yawning. Whew. Reflecting a point across an axis changes the sign of one coordinate, right? That's a great thing to highlight. Okay, actually that whole thing. All right, that's kind of like a shortcut, right? You could actually perform the transformation, but if you remember this rule, you can just switch the sign of one of the coordinates. For example, reflecting point A, whose coordinates is 2, -1 across the x-axis changes the sign of the y-coordinate, making A prime 2, 1. So this is a good thing to connect. All right, if we have 2, -1 across the x-axis, we get 2, +1. Same with the y-coordinate. If we go across the y-axis, the sign of the y-coordinate will change. So it will become -2, -1 instead of 2, 1 or 2, -1, right? You see that? We go from this here across the y-axis. Now the x-coordinate changes. We go across the x-axis, the y-coordinate changes. Kind of backwards from what you'd think. Okay? Great. Let's go on to the next bit. And it shows us that same thing here, right? So we've got A, we reflect across the x-axis here. Our x-coordinate changes its sign. If we go across the y-axis over here, reflect across that, then the x-coordinate changes. Ta-da! Not so bad. That's a really neat trick. It's a good page to have. All right? Reflections across other lines are more complex to describe. We don't have the tools yet to describe rotations in terms of coordinates in general. Here's an example of a 90-degree rotation with center counterclockwise, or with center 0, 0 in a counterclockwise direction. Okay, now if you're looking for a pattern here, right, you can notice that both of these were positive. We went 90 degrees counterclockwise across the y-axis, and that changed the x-coordinate because we went across the y-axis, right? So a similar thing with rotations kind of tends to happen, but that's only if the center is the origin, the point 0, 0, but also rotations are kind of complicated like this. They're very, very specific. You're only going to see this pattern happen with rotations, like I said, if we're rotating around the origin, and that's just the way it is. Okay. Now, point A has coordinates 0, 0. Segment AB was rotated 90 degrees counterclockwise. That's good information they're giving us. They're telling us what kind of transformation. The distance was 90 degrees. The direction was counterclockwise. And what was the center? Center was A. Point B with coordinates 2, 3 rotates to point B prime, whose coordinates are -3, 2. And that is that part of the lesson. We've done the lesson summary. So let's go back to this one up here, okay? And we're at 24 minutes. I got time for this. Okay, so I'm kind of going to show you, if you want to, actually, you should, if you got time, take 5 minutes to give this a go, okay? See if you do the reflections, do the rotations, and see if you end up with the same thing that I get. So I'm going to go ahead and, go ahead and pause it right now. Okay, if you've unpaused it, good work. Check this out. Okay, so it says rotate segment. I'm looking at this first one. All right, rotate segment AB 90 degrees. So we're rotating 90 degrees counterclockwise around center B. Great, easy enough, right? So we've got center B. We've got this line here. I'm rotating 90 degrees counterclockwise. So this is the way the clock hand goes, right? That red hand. So we're going to go the opposite way, right? And it's going to be 90 degrees. So does this look like a 90-degree angle? It sure does. And we can use that box rule too that I think I talked about last lesson, right? Where if we need to rotate this 90 degrees, I know this line goes from the bottom right corner to the top left corner of this box. So if I rotate that 90 degrees, my rotated line should also go from one of those corners to the other. And it does. So that's a 90-degree rotation. We're all set there. Okay, that's fantastic. Center B did not move because it's center of rotation. We went counterclockwise and it's 90 degrees. And it looks like a very similar line. So now let's do in purple. Purple's so great. Rotate segment AB 90 degrees clockwise around center A. So we're rotating. Hello, I need that. Rotating 90 degrees counterclockwise around center A. Oh, I almost forgot up here. We got to label the coordinate C, the new one. So let's do this. This one we have to label it as D. Okay, so we're going around center A. I'm going to put my line there, and it's counterclockwise again. 90 degrees again, which I believe I have done. Yep, it's 90 degrees. And the new coordinate is D. All right, if you have both of those correct, way to go. Good work. All right, now this last one says rotate segment AB 90 degrees clockwise around 0, 0. Label the image A as E and the image B as F. What's the coordinates of AF? So we're rotating this whole line around the origin 90 degrees. Okay, so something that helps me with this. All right, I'm going to do this in like a fun color. Oh, this red's pretty great. Okay, so 90 degrees from the origin. What helps me with this if I make a box that kind of starts at the origin. I can kind of draw my line in here because I know that's where it's going to be. All right, now if I rotate this box 90 degrees clockwise around 0, 0. Let's try it. Oh, no, not all that. I just want to select that stuff. 90 degrees clockwise. It should be 3 spaces over, 4 down. Perfect. So we've got that there, and we can see our line goes from this point here to this point here. Let's erase all that, and I'll clear it up. Okay, great. Let's connect those lines. Fantastic. All right, if you have that line in there, give yourself an extra good pat on the back because this is really tough. If you're not able to do this last one, that's number 3, that's okay. If you had a lot of trouble with it, it's all right. I do want y'all to be able to do D and C, right? If you weren't able to do EF, that is okay. All right, that's kind of a challenge on this assignment. Okay, let's look at number 4. Compare the two 90 degrees counterclockwise rotations. What is the same about the images of these rotations? What's different? All right, well, something you might have noticed here is that the angle of all of these 90-degree rotations is the same. We rotated them in different directions, but because they're 90 degrees, the angle of each of these lines, right, is going to be the same, okay? Because it's 90 degrees away from this line, okay? It'll line up real well, all right? So that's that. Oh, is that activity? Oh, sweet. So, fantastic. We could say when we're comparing them, the lines have the same angle. What's different? Well, the points on the lines are different. They're all in different locations, right? Ooh. And that's the difference. So at this point, we're about 29 minutes into the video. Given that you've taken maybe 10 minutes or 15 minutes for the activities, should be getting pretty close to the end of class. Now, if you're not, or if you didn't and you kind of rushed through, okay, I do want you to be doing, we are working the entire class period, so I do want you to do those practice problems on page, let's start on page 43. Okay, do those till you get to the end of class. See how you feel about them. If you want the answers to them, check out the Mr. Morgan videos, just if you want to check your work. Okay, I'm not going to take any more time to go over them because, well, I could. Nah, I want y'all to work on them. Okay, so if you want answers to these questions, you can ask me, or you can look them up. Look up the Mr. Morgan video for this lesson. Okay, but give them a go. See if you and your desk partner can get to the same conclusion on these ones. All right, if you've got time, of course. And if not, hey, have a great weekend. All right, thanks for an awesome first week of school. I know I was only here 2 days, but y'all's are killing it. Okay, good work. All right, thanks a bunch, and I'll see y'all's on Tuesday. All right, well, I'll see you in the Monday lesson as well. Okay, I suppose. So have a good one. Bye-bye.